So let's go over how to solve a programming problem like this one. For this programming problem, we're going to make a table to display the velocity of water through piping of different diameters, given the water flow rate. And here's our equation. Our velocity equals our water flow rate in meter cubes per hour divided by 3600 times pi multiplied by inner diameter of our pipe in meters squared. So for this problem, we're going to assume that the water flow rate is a constant and is 30.562 meters cubed per hour. We're going to go ahead and make a function that's going to calculate and return the velocity through the pipe given the diameter of the pipe and this water flow rate. And we're given the header for our method, and it's going to look like this. So a good way to start a problem like this is to go ahead and start by writing this method and implementing this equation. So if you haven't already, start Eclipse and create a project and then create a class. Remember to always write your name as comments at the top. Let's write that method. Remember to put that method outside of your main method but before the end of your class. Eclipse is yelling at me because I said I'm returning a double in this method and I'm not returning one yet. To get rid of this error, just return a double. I know this is not what the function is supposed to do, but this is called a stub. We're just making it work so that it will stop with the error. Alright, let's go ahead and find the velocity. Remember to use the given equation. We have our water flow rate divided by our 3600 times pi multiplied by our d divided by 2 squared. So we translate that equation into how we write it in programming code. Note the important parts when implementing an equation like this. Our order of operations, and then we're not performing int math. We need to put these parentheses here so that we do our order of operations correctly. Remember that we should always use our pi from our math library to get a more accurate result. Most programming languages have a math library or a math class, and in that math class is a variable called pi. Remember in Eclipse, you can always type the name of your class. We know it's a class because it's going to have a capital letter. Use the dot operator, and it'll bring up all the variables and methods for that class math. And there's our constant pi. Remember also that when we're taking the power of something, like diameter divided by 2 squared, we can use our pow function from our math library. Remember, if we ever forget our pow function, if we use that dot operator after our class name, we can look for that method in this drop-down autocomplete menu of Eclipse. And it'll show us all the methods of the math library and what they do. It's very convenient and a very helpful tool. I find that velocity and then I return it. Note that I could have written these 2 lines of code in a single line of code. This single line of code will do the same thing that the 2 lines of code did. I will not grade you down in your test if you write 2 lines of code. Sometimes when we're first beginning, it's good to see how this method is working by writing 2 lines of code. But most programmers would write their code like this. By creating this variable, we made our method a little bit inefficient because it makes this variable and then destroys it when it returns. So there's no need to make this variable if we just return what this function calculates. Also remember to get rid of this auto-generated to-do comment. We can write our own comments, and I don't mind if you change this comment, but get rid of the automatic generated text. The second step when doing a programming problem like this is to test that we did this math correctly. So you write some test code in main. We go ahead and call our method inside of main, and we gave it 2 arguments. Remember that these arguments are copied to the parameters, and those values are used in the method. We hard-coded a 1 and the 30.562 for the water flow rate. Note that these arguments have to be in the same order as our parameters, or we're not going to get the correct answer. Remember to test your code before moving on to making the table. Alright, let's go ahead and make our table now. When making a table like this, you should use a for loop, because you know how many rows you need to print out. In this table, we have 10 rows. Also, when making a table, look for a column in your table that you could use as the variable for the control of your loop. Our pipe diameter would make a great control variable for our loop. It starts at 1, it goes until it's 10, and it increments by 1 on every loop. So we create our for loop, and we use a variable that we call d that will represent our diameter of our pipe. We started at 1, we go until d is less than or equal to 10, or less than 11, and we increment our diameter by 1. We took that test code and wrapped it into this for loop. We'll go ahead and change our 1 into that variable d that's going to iterate in our loop. We can go ahead and leave this here because our water flow rate does not change. And we print out our velocity. Note that it's not formatted correctly, but we are getting the correct answers for our velocity of our water through the pipe with the corresponding diameter. Now we need to change and make our output look nice. So let's change our output to where we're printing out the diameter of our pipe, and then a tab character, and then that velocity. Remember to make one change at a time, and then see what your table looks like. Alright, we're looking better. Now I'd like to put a header onto this table. Remember to write the header for your table outside of your for loop because you only want to print it out one time before you print out the rows of your table. Test your code. Alright, we need to tab this water velocity over a couple of tabs. Make a change, test your code, see what it looks like. It's looking better. Now we need to format this water velocity so it looks more like the table that I've given you. In the table I've given you, the output is to the 9th decimal. So I'm going to go ahead and use this decimal format object to format my output to the 9th decimal place. If I want 9 decimal places to show, in my constructor for my decimal format object that I named df, I'm going to go ahead and write this string which says to print out 9 decimal places. I then use this decimal format object and his format method to format that velocity to 9 decimal places. Remember to test your code. That looks pretty nice. Let's move on in our programming problem. The next step is to write this function for our volume. We're going to find out how long it takes to fill a water tank with the following dimensions of a cylindrical water tank. Here's our volume equation, and our output will be in meters cubed. Remember, a good place to start is by implementing the method, and I've given you the function header. Remember to write this method outside of any other method and use the function header that I gave you. Math.py times radius squared, and remember that you can write radius squared with the POW method, or since we know radius squared is radius times radius, it's okay to write it this way as well. Now that we've implemented that method, let's test it. In our main method, we're going to find the volume of a cylindrical tank with a radius of 4 meters and a height of 12 meters. When I give you a question like this, you could answer it in your code and print the answer to your console. Remember to write the answer to this outside of the for loop because we don't want it to be part of our table. We're outputting a new line to skip a line after our table, and then we're outputting some text, the volume of a tank with a radius of 4 meters and a height of 12 meters is. We call our method. Remember, you can always think of a method as what it returns. So since this method returns the volume, returns a double, we can print out that double right in our system out print line and not store it in a variable. Meters cubed. Let's go ahead and run this code. It's looking pretty nice. I'd like to format this a little bit better, maybe to 3 decimal places. So if I want to format something to a different number of decimal places, I'll go ahead and make a new decimal format object. I'll then use that new decimal format object to format that double, which volume is returning. Remember to run and test your code. That looks pretty good. Now on to the thinking question. Find how long it would take to fill the cylindrical tank, this cylindrical tank, with water using a pipe that has a diameter of 2.5 meters and the given water flow rate, which is constant and is 30.562 meters cubed. Think about how to answer this question before continuing on in this video. Think about the algorithm you're going to use to solve a question like this. A good way to start an algorithm is to think about your input. We're given that the diameter of the pipe is 2.5 meters, and the water flow rate is this 30.562 meters cubed per hour. We need to have an output in hours, or time. Think about how we're going to get an output of hours. Let's see. Water flow rate has hours, but we need to get rid of this meters cubed. What else do we know that has meters cubed in it? Our volume. Let's think about this problem. We need to know how long it's going to take to fill this water tank. Our water flow rate is the amount of water flowing into the tank. It didn't really matter how big our pipe was. When we look at our output, we can see that our velocity actually goes down as our pipe diameter got larger. This is because the pipe got larger, but the water flow rate stayed constant. Remember to think about your inputs. That water flow rate is the amount of water flowing into the tank. The amount of water is not changing, so it doesn't matter how big the diameter is if I want to see how long it's going to take to fill something if the water flow rate is constant. To figure out how long it takes to fill this tank then, I just take how big the tank is, or its volume, and divide it by how fast the water's flowing in. Then I'm going to get the amount of time it takes to fill that tank. So I implement that equation here in this nice little output of my answer to my thinking question. The time it takes to fill a tank with a radius of 4 meters and a height of 12 meters, and a volume of, and here's where we just copied and pasted our volume that we just figured out. We then take that volume and divide it by our water flow rate. We can see that it takes about 19 hours. Now let's try to fix our code. Now that we have it working, and we have it mostly formatted, let's try to make our code a little bit more efficient. To make your code more efficient, there's a few things that we could change. Note that our water flow rate stayed constant. For this programming problem, since we're given that the water flow rate is constant, we can make it a constant variable. That way, if our water flow rate ever changes, it'll be easy to just change that constant variable, and our program would work the same way. When making a constant variable, we make that constant variable outside of main with the keywords public static, and then we're making a double. Whenever we make a constant, we use all capital letters. because that's a Java standard. We then initialize it to 30.562. This variable is never allowed to change unless we change it here in our code. We then can use this water flow rate in place of hard-coding this number. Note that this makes our code easier to change. If our water flow rate ever changes then, I would just go up here and change this variable one time in my code. As opposed if I left it the way that it was written before, I would have to make 1, 2 changes, and maybe many more if I used this water flow rate other places in my code. This makes my code more efficient in changing my code, because I only have to change the code one place to change that water flow rate. Note that I left this parameter here, water flow rate, and I did that so that this method would be more adaptable. If I hard code the water flow rate here and get rid of this parameter, note that my method would still work if I got rid of these arguments here. But I've now made this water velocity method only work with that constant water flow rate, which kind of limits the functionality of this method. So I think it's better to leave that parameter in there so that we can use this water velocity method in different situations. Let's see how else we can make our code more efficient. Notice that we're calling this volume method several times in our code. This makes our code run inefficiently because every time we're calling this method, it's going down here to the method and recalculating. But we only need to calculate this one time. Calculations take time in a computer, so if we can limit the amount of times that that calculation is made by storing it in a variable, it makes our code run more efficiently. So replace in your code the calling of that method with the value of a variable. Remember to always test your code after you made that change to make sure it still runs correctly. Alright, so this is an acceptable answer to this programming problem. Until next time.